Good afternoon. Thank you for attending this presentation with the title Is the Ecological Status Assessment Result the Same using Genomic and Morphology-based benthic biotic indices? As you know, when monitoring and assessing marine benthos, there are different biotic indices that can be used. One of the most used is AMBI, Astis Marine Biotic Index, which is based on samples taken. You can assign to each of the species in the sample to one of the 5 ecological groups based on the tolerance of a species to the disturbance from sensitive to opportunistic species, and looking at the proportion of each of these species of these ecological groups, you can calculate or obtain a number between 0 and 6, in which 0 is the high ecological status and 6 is the worst ecological status. Hence, if you take the sample and you pick up all the species, identify the species and count, then you can calculate using a software this AMBI value. However, if you have many samples, this has a high economic cost and also takes a long time to obtain the information, and you need also taxonomic expertise. So we were thinking about different alternatives, and the best could be the use of genomic approaches. And in 2014 we developed genomic GAMBI, which is the same index but based on molecular information. In 2018, we published this paper in which we compare the taxonomic composition using the morphological information or using the molecular information, and even more, we were able to relate the number of reads with the abundance and the biomass, and you can see that in both cases the correlation was quite high. So we can now use the abundance, not only presence, absence, but also the abundance, taking into account the number of reads for macroinvertebrates. However, the official assessment method used in several countries in Europe is MAMBI, which is the multivariate AMBI, which includes not only AMBI but also richness and diversity. And this methodology was intercalibrated among the different countries using it in Europe. However, when comparing morphological MAMBI with the molecular MAMBI, you can see that the correlation is not so good, and hence we need to check the relationship between the morphological and genomic results for AMBI, richness and diversity, especially for the reference conditions needed to calculate this MGAMBI. And this should be calculated for each type at sea. Types could be assimilated to communities or areas with the same conditions. The methodology we use here in this presentation was taking samples at sea using bumping graphs, both for molecular and morphological analysis, further analysis, sieving the sediments and pick up the different individuals, and then using the morphological identification or the metabarcoding in order to identify in both using both methods. We did this in 22 stations with 3 replicates at each station and 6 years with annual surveys, but for this presentation we have used only 3 years to set the reference conditions for richness, diversity and AMBI, both for the genomic-based methods and to calculate MAMBI and MGAMBI, and to intercalibrate with the current accepted assessment methods. And we did this for 5 types of communities, 5 types of areas. But some standardization to make comparable morphological and genomic data is necessary. We only left genus and species level to compare both morphological and metabarcoding, but we left also Nematoda and Nemertea. And then for Olicocheta, Insecta, and Diptera, we sum up all the reads from species and genera. Also, we remove all taxa with less than 10 reads by replicate. And in the case of M. gambi, is factor analysis, and to assess the status, we need reference conditions of bad status. For gambi, we use 6 as the worst situation, and for richness and diversity, we use 0 as a azoic situation. And we use an adapted reference conditions of high status for each type, and we have 6 types, 3 in estuaries, following the gradient of salinity from oligo-mesoalign, polyalign, eualign, and in the coastal area we have 2 different depths, one more shallower, and the other more deeper. For gambi, we use the lowest values obtained at each of the different types, and for richness and diversity, we use the highest values obtained in the samples. The results for the 3 first years are, when comparing ambi and gambi, you can see that there are good correlation comparing both methodologies, and when you compare by types, the different types, you can see that for example, for type 1 we have only worse situations. In the type 3 we have the whole gradient, and in other types, especially for coastal areas, we have only good status areas. When we compare richness for the both morphological and molecular data, you can see that the correlation is a bit worse, but again, the problem is that for low richness, in the case of morphological, we have still high richness in the case of molecular. And taking into account the types, we have more or less this even distribution. When comparing the diversity, the correlation is the worst, and in this case, with again with low values for the diversity in the case of morphological, and relatively low values, but still high for diversity based on molecular. And here you have the distribution for the different types. When comparing ambi based on mambi in morphological and m-gambi based on genomics, with the reference conditions for each of the types, you can see that the correlation is not very good, and the problem is again that for the worst status, the bad status in the morphological, we have still like poor or moderate status in the case of molecular, which is not very good. So we calculate then with different reference conditions, and we improve a bit this part, but still is not very good. And this depends on the richness and diversity mainly. As conclusions, we think that we have successful results with gambi with immediate application, including also abundance and biomass, so it can be used already. But still, we are facing some problems when calculating m-gambi. The difference comes mainly from diversity and richness compared with the morphological results. I think that it is important to set adequate reference conditions for molecular methods, and especially this must be set at the type level. And we need to have the whole gradient of the gradation for each type, And this is difficult to obtain at this moment in our area, because in the last 20 years it has been restored, and there is still very few stations with less than good status, less than good ecological status. The intercalibration is needed for the application of the Water Framework Directive, and playing with the ecological status boundaries, we can probably increase the intercomparability with the morphological results, and we will try to do this in the near future. So the response to the title of this presentation is no. Currently, the genomic methods does not yield the same result in the ecological status compared to the official method. We expect still 3 more years for adequate comparability, and there are still shortcomings in using genomic methods, for example, standardization and comparability among laboratories, taxonomy, the application of in the Water Framework Directive and the Marine Strategy Framework Directive compared with previous indices could be problematic, but they can be overcome in few years. And finally, in our opinion, the future of monitoring and assessment could be based mainly in genomic methods if we solve the above problems. Thank you very much, and I'm open to your questions.